So at this stage, let us look at some exercises. Right? I'm going to use some example here. Right? Let's say P. Right? Let P here is a X is a factor of 4, and Q, X is a factor of 12. Alright? Is P implies Q true? Right? Is P implies Q true? So before I do this, you may want to attempt this yourself by pausing the video as usual, and once you're ready, you can check your answer by resuming the play. Alright, so how do we tackle this question? So let us first use list out all the members in P. For example, P is a factor of 4, so actually we have 1 times 4 is 4, alright? And 2 times 2 is 4, so these are the only factors, there are 3 elements. How about Q? Well, Q, factor of 12, 1 and 12, that's 12, or we can have 3 and 4, which is also 12. Oops, and we also can have 2 and 6, right? 2 and 6. And that's it. So 3 and 4, 2 and 6. Oops, let's put in the order correctly. Alright, so these are the things. And then, well, from here, we can really see that set P here, this is capital P and capital Q. Right? Capital P and capital Q. Right? Capital P here is basically a subset of Q. So this is true, right? Since P is a subset of Q, then P implies Q is true. So that's the answer. Alright, let's try another exercise number 2. And this particular one, P, X is less than or equal to 0. Q is X is less than 5. Okay, is P implies Q true? Right, as usual, you may want to pause the video, attempt it first before you check the answer. Okay, for this one, listing here will be difficult because we're dealing with all real number. So I'm going to do a number line, real number line with X, and here is 0, let's say, and here is 5. Example. This one, P is like this. Closed circle because it's including. That's capital P. Right? And that means all the X value that satisfy this condition P here, that is, X here must be less than or equal to 0. And for Q here, this is open circle because it's not including 5. And here is my Q. Right? And you now see, well, it's very obvious now, P is a subset of Q. Right? So that since P is a subset of Q, then P implies Q is true again. Right? That's it. Alright, this is relatively easy to do. Now, you want to try that example? Alright, so this one I'd like you to try yourself. Question number 3, and you may want to consider P in this case. Right? X is greater than 0, and Q is negative 2. X is larger than negative 2, but is smaller than 2. Right? Is P implies Q true? is P implies Q true. Alright, this one you may want to try it out yourself first before you check the answer. Okay, let's check the answer. Alright, so I do the real number line again, x, and I put a 0 here, and a -2 and 2. Now, everything is larger than 0. This is larger open circle, and here is this is my capital P. That is all the sets that contain that are larger than 0. And next, I have -2 to 2. This is my capital Q. Right, from this diagram, it's obvious that P is not a subset of Q. Then we must conclude that P implies Q is false. Alright, so today we talk about implication. Implication basically is a if-then sentence. If a particular condition is satisfied, then we have a particular result. We read this as P implies Q, and we can also read it as P is the sufficient condition for Q, because if you are in Karizawa, then it is sufficient to know that you are already in Japan. If Q is the subject, Q is the necessary condition for P. So in order for you to be in Karizawa, you must be first in Japan. So that's the necessary condition. And P implies Q is true if P, capital P, is a subset of Q. That is, all the things that make the sentence P correct is in P is a subset of capital Q. Right? Here are a few examples. If P is not a subset of Q, P is not a subset of Q, like in this particular case, then capital P is not a subset of capital Q, then the statement, implication, P implies Q is not true or false. Thank you.